And as usual, guys, welcome this evening, Saturday evening. And thanks for sparing your time. Uh, I think many of you might have planned to go out on Saturdays, but you cancelled and joined this class. So this shows your passion to learn. And I'm Shailendra Kadre, as usual, your host for today. And I am a freelance trainer as well as I'm a visiting professor in a couple of colleges. And so today we'll learn something about convolution neural networks, which is an advanced topic to which comes after artificial neural networks, which are both most basic neural networks. So most basic neural networks are nothing but advanced, what we call as ANN, artificial neural networks. Once we have finished that, next stage is to we come on CNN. Okay, so we'll see what is CNN, why we need CNN, and what makes them special. Okay, so I make it full screen. Then we go ahead like CNN's like is very much you can see this is the more or less like a ANN only, ANN network. You can see the input layer, output layer, and there are 3 hidden layers in this, all densely connected. But what it is used for? It is used for classifying images. So when it comes to classifying images, ANNs are not that useful because a number of features which we have to deal with in while classifying images are very high. So we somehow reduce the number of features first, and then we apply some kind of neural network on the top of that. So that's where a specialty of convolution neural network comes. Like suppose you have a bird image like this, which is shown here. And it is 256 by 256 pixel, 256 wide, 256 height, 256 by 256 pixel. So 256 multiplied by 256, that many features will be there in the input image. So it is very difficult to deal with such high amount of dimensionality. So 256 into 256, can somebody calculate and tell me how much it will be? 256 into 256, can anybody calculate? I will just try to calculate it in Google. 256 by 256, okay. So this number is nothing but 65,536. You see here number 65,536. So total number of input features will be 65,000, and it is simple image. It is not a big image. 256 by 256 pixel is not a big image. It's a simple image, small image only. With that, you have to deal with 65,536 input features. And for each input feature, you have to give 1 neuron. By rule of thumb, for input feature, you have to give 1 neuron. So you have to give 65,536 neurons. So such a huge number if we deal with, then we need very high computational power. Your number of trainable parameters will be very high. So a lot of problems will get ourselves into a lot of problems computationally and managing the overall dimensions of CNN. Very high input by very high number of input pixel. Then subsequent hidden layers also will have very high amount of neurons. So it will be a very huge image, and it may not be possible for us to even Google Colab Pro. If we take a professional subscription, we may not be able to do in that also. We need special computers, which maybe that Microsoft and Google only will have those kind of computers. So what we generally do, what we do when we have to deal with such a high amount of dimensionality, so we have techniques to first reduce the number of dimensions of the image. So there are 2 techniques. One is called convolution, and another is convolution. We reduce the number of dimensions using convolution. Once convolution is applied, we applied pooling on the top of convolution. We'll further reduce with the help of convolution. So convolution pooling, these layers go together. And why we do that? To reduce the number of dimensions. And now what is convolution? What is pooling? We'll see going ahead. Going forward, we'll see what are these things. So basically, CNN is a convolutional neural network, and specifically it deals with the images. Images means basically images. It deals with the images. So images means there will not be any regression, right? So it will be only classification. So these kind of images will be supplied as input. So then your CNN network will classify whether it is dog, whether it is bird, or whether it is a cat, or there are 1,000 kind of, suppose there are 1,000 kind of images in your data set. So there will be 1,000 classes in the output layer. So like that, it will classify it into 1,000 classes. It will be a multi-class problem. So that is the motivation behind CNN, that it is used to deal with images. So when we deal with images, it is very important for us to understand images. What is a digital image? What is it? We should understand that first. Then only we'll be able to deal with that. So we have already discussed that it is used for image recognition. Image recognition means 1,000 types of image will give, and our network, neural network will separate them into different classes. That is the task given to CNN. Now, before that, let us see what is digital image is and what are challenges in dealing with digital images. Let us see that. So a digital image of this lady, actually fantastic image we see on the right hand side here. So image is nothing but I think some of the other idea we have for digital images. So every photograph, like a photograph, or every image, whenever we do a scanned image in a scanner, we say it is, say, 150 by 150 pixels or 75 by 75 pixels. So everyone knows that a digital images is made up of pixels. So pixel, we say it is pixel. But if I ask you a question, I think many of you will not be able to categorically define pixel. So I give you a chance, you people a chance. What is when I say it is 256 by 256 pixel, what is mean by one single pixel? What is the meaning of a single pixel? Anybody wants to take a chance? What is the meaning of a pixel? What is mean by a pixel?
One small grid.
One small grid, but what does it represent? You are right, very much right. One small grid. One small grid of the, one unit grid of the image is called pixel, right?
Yeah.
So what does it represent?
Sir, 1 byte.
Pardon?
Sir, 1 byte.
7 byte, correct. That also, not 7 byte, it represents 8 bytes. 8 byte it represents. But what is it actually? What is the physical significance of a pixel?
It's probably the.
So it is a representation of
Word. I think there's some.
Yeah, it is representation of like some light or dark.
Yes, you are right there. So it is representation of intensity. Every pixel is given a number between 0 to 255. Is divided into 256. 256 intensity levels are there. So 0 to 255 means there are 256 intensity levels are there in the pixel. 0 means perfect black. 255 means perfect white. And grayscale means there will be in between numbers. Okay, so that's what a pixel is. So pixel is nothing but a small unit square of a square unit of a digital image. So now we understand pixel. We understand what pixel contains. So it contains the value of intensity of light. So if it is perfectly white, its value will be 255. It is perfectly dark, its value will be 0. And if it is somewhere in gray, so it may be either 10, it may be either 100, it may be either, depending upon how bright it is. So understood, right? So that is when it comes to it is when the pixel is black and white. Only one channel is there. Only black and white we are talking about. So what about if image is color image? Anybody wants to take a shot? Color image?
Yeah, it's a combination of blue, green, and red thing.
Yeah.
So if 0 to 256, each one has 3 vectors.
Yeah, right. I think you are right. So see, any blue, see, first of all, when we call 0 to 256, each pixel is given 8 bytes, 8 bits. 8 bits given, pixel is given 8 bits computationally. So then I'm not going into details of what is bit, what is byte and all that. So it is very bit computer science. If you have any challenge, I think you should do a little Googling. What is a bit, what is a byte? So all those kind of things you should. So each pixel is given 8 bits. 8 bits given. Every pixel is given 8 bits. So now when I say color image, it is consists of 3 channels. Channels means 3 colors. You can say red, green, and blue. These are 3 basic colors in the nature. With the combination of red, blue, and green, I can create any color in the world. So there are millions and billions of the color in the world. There is no limit. But they are all basic constituents are red, green, and blue. That's what is the constituent colors. With the proper combination of red, green, and blue, I can create any color in the world. So when I say combination of 3, red, blue, and green, so red also 8 bit, green also 8 bit, and blue also 8 bit. So combination is my grayscale image, my color image is always 1 bit is 24 pixels. Understood? Every pixel in a color image is a combination of red, blue, and green. So red also 8, color green also 8, and blue also 8. So it is combination. Every color image bit is a 24 pixel. Understood? Every black and white pixel is 8 pixel. 8 and 24 understood. Okay. Now see how RGB looks like. Very simple. Vegetables shown on the left hand side shown RGB image, which you see usually as an image. And when I see red channel, green channel, and blue channel, I have given you some representation. I have given you when it is so top is pure red channel, in between pure green channel, and in below it pure blue channel. When I keep each green above the red and blue above the green, means on the top of each other, if I keep all the 3, it becomes the RGB, the natural image we see, like that. That's how it looks like. Couple of more examples we'll see. So RGB 3 channel, and when we do integration, it becomes. Let us not get into this now. So this is our simple image taken on the left hand side. Again, I am giving you 3 channels RGB. One more representation, just to give you an idea how it looks like. Then let us go to a grayscale image 8. You have seen this 8 image on the right hand side. You see right hand side image, which on the 8 image. So it is a simple 8 image drawn with the help of a computer. So when I say each pixel is 0 to 255, then it becomes a left hand side image. You see left hand side. Left hand side, every pixel there is a number given. If it is white or near to white, the number is either 254, 253, 246. So these are near to white. And the dark images, the dark pixels you see, the dark pixel is either 0, 7, 1, very low values. So like that it becomes, or each pixel is given value here. Understood? So each value of pixel will be now the value of pixel will be 0 for black and 255 for white. So this is how when I give a number, it looks like. Very simple, original image, pixel representation. We have seen that. Now, if I do some kind of normalization, normalization means every pixel I have a value is 255. I divide it by 255. So all the values will be lie between 0 and 1. What I am doing, each pixel number, whatever number I have, I am dividing it with the maximum value number of 255. I am dividing it. So each pixel now we have a fraction between 0 and 1. So it will look like this. So it is called normalization of the image. 1 means very dark, and like 0.9 will be little white, and then when value reduces, then it becomes less and less. Now I have a dog image here. Color image, which is left color image, I have a dog image. I think left dog only. We found one lap dog in Shobha Forest View also, right? It's a similar image. So left hand side you see a lap dog, Labrador, and then right hand side if I divide into red, blue, and red, green, and blue channels, and then each of the channel I have pixel representation here. So each channel value will be between 0 and 255. So like this, these three channels will be there. And when I keep them on the top of each other, my original normal image becomes. Okay. Now this is we have understood about color images. So how a black and white image looks like and how a color image looks like. That's what we have understood. Now let us get a step ahead. Let us get a step further and see what are the challenges in dealing with images. When we deal with images, what are the different challenges? Now the very first challenge is, see, this is a person's photo I have shown, like the same person, but you see the viewing angle. One is straight and then is looking down, then looking sideways. Then viewing angle is different. So you are given the person of same image, say Mr. Modi or any big shot image is given, and you have to your image, your CNN network has to recognize whose image is this. But you cannot tell the person who has given you image that I want front image, front, like I have to take photo from the front only. The photo can be from sideways, the photo can be from up. So all these conditions you have to take into account, and you should still be able to recognize the person. Whatever viewing angle is, whether it is front image, little from top or little from side, whatever is the viewing angle, you should be able to recognize the person. That's what is the challenging job for a CNN network, your convolution neural network. That is first challenge, dealing with images because angles can be different. This is the first challenge. I said today's session is very simple, and you will find it very interesting because you will understand everything today. So one is angle, then another is scale. You see here scale. I have a toy scale, a toy car here. First scale is 1/43, another scale is even smaller, 1/64, and third is same on the smaller scale, 1/148. So what I mean to say is, even a person of a cat or a dog or any famous personality photo is given to you. The scale may be very challenging, like very small portion of the photo may be the photo, very small portion of the image might be the actual face, but still you have to recognize. Means right now, whatever you see my video, so I am occupying this particular area, some particular area my face is occupying, which is smaller. But if I zoom a camera angle on my face, it may occupy, say up to 75% of that image, which you see here. Right? So that scale is another challenge. It may be very small, it may be very big, or it may be optimal to use. Another image is the background. Now you have to, this is a beautiful baby, say maybe our third or fourth standard, she might be third, fourth standard, looks like from some Western country. So now you are given the task to recognize this image. But image can have a lot of clutter on the back end side. See, she is sitting on a, say, her room. She's sitting, and a lot of things are there in the background. There are toys kept on the background, and then she has the glass, and then her playing things are there. Then a lot of things you see here. And right hand side photo, her only face is there. That is a challenging task. Still, your CNN image has to classify whether who's that lady is. In place of this small little girl, it might be a photo of a famous personality. So on that famous personality, lot of things may be there in the background in the photo. Still you have to recognize, or that photo may be a close-up shot. Still you have to recognize. So that is another challenge, dealing with images. Another challenge is the illumination. Of course, we know all this illumination. Little darker, little light coming from the left, light coming from the right, light coming from the top, light not there at all, night, day photo, evening photo. So illumination can be different in every photo. That is another challenge. Illumination can be different. Same face you see here, same face is there, but it is there in different illumination. So you still have to deal with it. That is another challenge. Then, so these are some common challenges which I will repeat. First is the angle. Second is the scale. Third is the background and clutter. And fourth is, which I have mentioned here, is the illumination. And that's not the end of the story. Here I have given these as a representative challenge. There may be many more challenges which I have not listed here, dealing with images. So dealing with images is not easy. That's what we see. Like if we see artificial neural network, your data set is having 10 features and one target variable. So 10 features, you give 10 neurons in the input layer, and you then you either do regression or you do classification. It's little easier. But here, as I told you, 256 by 256 image, the number of features will be more than 65,000. That is okay. But apart from that, image can be red, blue, green. That is one 3-channel image. Apart from that, there can be many more channels. Like RGB are very basic channels. But there can be many more channels are possible with the digital images, which define different aspect of the image. So there can be more than 3 channels. And then apart from that, you have these kind of challenges, which is illumination, then you have this clutter, then you have scale, then you have viewing angle. So dealing with image is not easy. Okay. So dealing with image generally means image recognition. Image recognition means image classification only. Okay. So if we are given 10,000, say 100 persons, your network should be classify who is Shailendra, who is Chutika madam, who is Malini madam, who is Ashwini madam, who is Shailesh Kadre, or who is Uday Soman. All they should be still, when you feed the face to that image, they should be classified. If it is trained properly, they should be able to classify with the name. That is generally that is the task in CNN, but it is very challenging. Okay.
Sir,
So, yeah,
actually, if we see this image, then
Yeah.
for a human eye also it is very difficult. Some of the photos, they are looking like Hrithik Roshan, while the others are not.
Yeah, you're right. Yeah.
So actually, when we are creating the algorithm, some perfect algorithm, will it work better than the normal
No,
human
madam,
eye?
nothing will be better than human eye.
Yeah.
And for us, it is very trivial to identify image. We can identify in
Yeah.
any condition. God
Yeah.
has given so much power. It is very trivial for us to identify images, but it is a very big challenge for neural networks.
Mhm. Yeah.
And still, there is no, in my knowledge, there is no CNN image neural network has made which is better than
Human eye.
human eye.
Okay.
Under certain specific circumstances, certain circumstances it may be better, but in general, human eye is the best. Because behind human eye, you have a supercomputer, no brain,
Yes.
which is having billions of neurons.
Yeah.
So behind that brain is working, right? Which is having billions of neurons. So it is very God gift, madam. It's a very big God gift actually. CNN, our eyes are and mind. Eyes is a big, nice camera, including with our CNN of our neural network of our mind. It becomes a very sophisticated convolution neural network. Okay, so now let us get into little bit details of CNN. So first layer will be your input layer as usual. Generally, then we encounter one convolution layer, then one pooling layer. So I'll tell you what is convolution, what is pooling. It is very easy arithmetic. Nothing, the names are big, but mathematical concepts are simple arithmetic. Only even a 5th class, 6th class boy can understand that. So input image will be given. After that, we'll do convolution. After that, we'll do pooling. So these 3 combination. After that, I have written here to see feature extraction. So these convolution, pooling, and input layer together will, like convolution and pooling, what they will do? They will reduce the number of features which are given as input. Input, you will give thousands of features. In convolution, you will reduce one step, and with pooling, in pooling, one more step you will reduce. So reduced number of features you will get after these layers, convolution, pooling. So that is feature extraction. We are extracting features out of the image. So we have to reduce dimensions of the image. We have to reduce. But still the important feature should not go, because you have to recognize the face and those kind of things. Now. So if I am wearing specs, whatever convolution or pulling operation I am doing, my specs should remain intact. Okay, because image has to recognize me by specs. Okay, so those kind of features in the face, or feature my mustache or my beard or whatever, if I'm wearing this headphones, so those kind of features should remain intact. But still we have to reduce the number of features. That is, this is feature extraction. After once we extract the feature, then we feed it to a simple neural network, ANN, simple artificial neural network, which is a dense layer. This is a dense layer you see. It is a simple hidden layer, and it is fully connected with the output layer. So it is a simple ANN actually. Fully connected layers are simple ANN, and that ANN what does, whatever features you have extracted till pulling, and then this ANN will be used to classify those features. And why there are three neurons in the output? Can anybody tell that? We have discussed it. Why there are only three outputs in the neuron? So why there are only three neurons in the output?
Probably a 3-class classification.
Yeah, it's only 3-class classification. Okay. So this fully connected layer, dense layer, is nothing but your simple ANN is there. It is a simple classification ANN. Right now I have shown only one layer, fully connected. There may be multiple layers, like fully connected layers like this in the ANN there. And I have here shown only one pair of convolution and pulling, but in actual there can be n number of convolution and pulling. Convolution, pulling, convolution, pulling, convolution, pulling. I can have n sets like that. Depends on, and there is no standard that how many can we have? How many should we have? How many can we have? There is no limit to that. There are some networks in which we have 200-300 layers, 200-300, and even more than that networks are available. Yeah, and these dense layers also, there is no limit. How can I put? I can put 1, I can put 3, I can put 10. And in dense layer neurons also, there is no fixed mathematics. So I can put whatever works, whatever gives me good results, I can put. So, but there are some rules of thumb, and some people have developed through their experience. They have given some rules of thumb that you should put in multiple of 2, or those kind of some rules are available, but they are not very hard and fast like mathematics. So this is all more arts actually. All this is called all CNN architecture. That how many pairs of pulling, convolution and pulling I should have, how many dense connected layers which I should have. So this is all this combined forms the neural network architecture. So this is a art actually. So whatever works for me, I'll do that. But at the end, the classification accuracy should be good. That is my aim. So with this aim, we go ahead. And this is the input. This is input. There is simple diagram I have shown. Nice diagram. That's nothing more than that. Then you have convolution pulling. Then you have again convolution. I mean, whatever pulling is giving output, it is on that output we are doing convolution, and then that convolution again we are doing pulling. So here 2 pairs we have convolution, pulling. 2 pairs are there, and then we have 2 fully connected layers here, and then we have a softmax layer. So can anybody tell me why here we have softmax layer and not sigmoid?
Multi-class.
Multi-class, right? Softmax. Whenever you have multi-class classification, you will put softmax, and when you have binary classification, you would put sigmoid. So this function is fixed for output layer. Okay. So this is the basic architecture of your CNN. Now we need to understand 2 things: what is convolution and what is pulling. Rest all we know. Fully connected layers we have already studied in our ANN. So there is no change. Image we have already studied what an image means. Now we should need to know 2 things: what is convolution and what is pulling. That's what we'll see. So convolution and pulling, I will not explain. Convolution, I will give you a formal definition. Convolution is to detect the presence of a set of features in images received as input, feature extraction. And pulling operations consist in reducing the size of images while preventing their important characteristics. Means they are telling that convolution layer will reduce the number of dimensions, and pooling layer will reduce the size, will further reduce the size by preserving the important properties, important characteristics of the image. So this is all round and confusing definition. Let us not get into that. We'll see them mathematically. Then it will be more clear. These are all round and confusing definitions. But just the sake of reading, I have read it. But you may not understand everything. Now, applications of CNN, if I say, whatever applications of I you have, that's where you can put CNN, automatic. If you want to replace a human with a robot, then you should have a CNN in that. You can put a camera. That camera will be input to a neural network, that which will be CNN. And then that robot can replace human. So you can put lot of tasks. You can do, say, a lot of tasks. You can, whatever task or you can do with eyes, the same you can do with CNN. So you have endless possibilities with CNN. One example I will give you. Simple example like face recognition systems in very secure establishment like military establishments and these people have face recognition, some kind of face recognition. So they don't go by fingerprints. So you have to stand in front of a camera. Camera will take a couple of images of your face and then it will classify whether Shailendra Kadre is allowed to go or not. Because already my face is feed into that. CNN network of that camera, that particular machine recognizes how Shailendra Kadre's face looks like. And once I'm standing there, it will match with that. And it will say, yes, he's Shailendra Kadre, let him go. So even if I have little beard, then if I clear my mustache, if I don't put this specs or don't put, if I put this headphone, if I don't put this, it doesn't matter. It will still recognize correctly. With beards also it will recognize, without beard also it will recognize, with mustache, without mustache also it will recognize. And whatever specs I put, and tomorrow I go to a spectacle shop and change the frame of my spec. But still it will recognize. It is Shailendra Kadre. They are so sophisticated. So that is one just example I have given. So again, same thing I have shown here. Convolution. ReLU means there is a ReLU function we have seen in ANN. So in CNN generally we use convolution plus ReLU function will use pooling, convolution plus ReLU, then pooling. Then you have flatten it. Flatten it means whatever output your pooling layer gives. So pooling layer will give 2x2 output or something, 2x2 output. So that you have to flatten. Flatten means you have to convert into 2x2 vector into a single column vector. Flatten it. Flatten it means like understood now, like it will be a square output or a rectangular output. So you have to flatten it into a straight line. So 2x2 vector, you have to flatten it into a single column vector before feeding into ANN. So there's classification. So last three layers are nothing but classification layer, which is your artificial neural network. So before putting artificial neural network, you have to convert it into a single column vector. Because that many neurons you have to give in the input layer of that ANN, right? So this is one more thing we have learned. Now let us see what happens. Like, let us see what happens to images. There is an image shown here. You see here there is a left hand side. There are the different layers I have shown. Just see the bottommost image. Bottommost image. We do the extraction in different layers with the help of CNN, convolution, and pooling. So first layer of extraction, second layer of extraction, third layer of extraction. And like that they are shown like feature 1, feature 2, feature 3 and label. So like that we convert it into a flat data set. Image is converted into a flat data set like this, which is suitable to feed in ANN. Just one representation I have shown here. So one set of features I take from here, one set of second layer, then another set I take from third layer, like that arrows are shown, right? So these features are taken like that from different places of the image. So let us now let us get little bit into technical into what is a convolution. So I said, I promised, it is very simple. It is simple 4th class, 5th class maths. So left hand side, I which is shown I, that is nothing but an image. I is an image. I is an image. Simple image. Each pixel is represented between 0 and 1. How? Why 0 between 0 and 1? That we have divided pixel values by 255. So 0 and 1 image is shown. Then another thing K, we call it kernel. Kernel or filter. It is same filter as putting on the top of camera. We put filter, na. So this is a simple filter. Filter is smaller. Filter is smaller, and we put filter on a particular area of the image, like which is shown in the pinkish color on the image. It is shown here in the left hand side. You see leftmost image, pinkish image. On that it is kept. And then we take a dot product. Dot product means every cell of that will multiply with the every cell of. So I will show you here, and that particular product, when we add up, then it comes 4 as a 4 here. I'll show you here, like you see here. Now you will understand. Leftmost layer, that is the image. In between small, you have a filter. Filter is overlapped on that particular image. Okay. So now what operation comes? So 4 will get multiplied by 0. Like 4 of the filter, number 4 of the filter falls on 0 of the image. So 4 into 0. Next, you go right hand side, first row. 0 of the filter falls on 0 of the image. So 0 into 0. Third element in the filter. 0 of the filter falls on the again 0. So 0 into 0.
So this is like matrix multiplication.
Matrix multiplication, simple matrix multiplication. And last one, what is important here is -4 falls on 2 here. Rest all are 0, 0, so they are cancelling out. So -4 falls on 2 here. See, there is a -4 is there on the filter, falls on 2. So it will give -8. So when we do add everything, it will becomes that is called first convolution. So first convolution will reduce to a single number. It will reduce to a single number which is -8. It will reduce to a single number which is -8. Understood? Then what we'll do? We will move this filter right hand side. We'll leave the first column of the image. First column of the image will leave, and we'll move the image right hand side. Like that, we will again do the convolution. It will again we'll get a single number. So like that, we'll get a smaller image, because you see each 3 by 3 portion of the image is getting reduced to a single number. So we are reducing number of dimensions, right? Here, anybody, any confusion? Convolution, what is convolution? Uddesh, someone? Uddesh?
No, sir, it's clear.
So can you explain what is convolution in your terms, so that people get one more point of view?
So convolution would mean selection of features using this kernel or filter.
But how can you explain the mathematical operation which is going on?
Yeah, the kernel is basically a matrix. So when it converges with the source pixel, like here, the 3 by 3 matrix converges with the 3 by 3 portion of the of our image. The result of that matrix multiplication, scalar matrix multiplication, and all those values summed up give us the result pixel, hence reducing the number of pixels. So now the 9 features we have is reduced to a single feature.
Yeah. So have you, Himanshu Sharma, have you got it? Simple convolution.
Yes, sir.
Himanshu?
Yes, sir. Getting it.
Getting it. And what about Shailesh? Have you understood?
No, -8 I have not. What is
See, why -8? You see, your pixel, your filter, you see, in between you have filter, right? That 3x3 filter is we have put on the image. So one area you are looking at, right?
Yeah.
Now you multiply all the elements of corresponding elements of the kernel and source image. So last right hand corner bottommost you see one is here is 2 in the image, it is 2 and -4 is there in the kernel. So -2 into -4 is -8, na? Correct, right?
Yeah.
Rest all are 0. One of the element is 0, so rest all are becoming 0. So all the element is the operation is given here on the top. You see, 4 into 0, 0 into 0, 0 into corresponding element multiplication. So -4 into 2 is becoming -8. So first convolution is getting reduced to -8. Got it?
Okay. So it's just a overlapping and
Overlapping and multiplying corresponding element. That's all. And then adding up everything.
Okay.
You overlap it, multiply all the corresponding elements, and add up. Got it?
Yeah.
Once it is done, then we'll move for second convolution. Second convolution means what? I will move one column right. I will travel from left to right. Okay. So right now I am in the very corner, edge of my kernel. Kernel is on the edge. Once one convolution is over, I'll move first column and move to the column number 2, 3, and 4. Understood? Then I'll do again same thing. So all 3x3 matrix is getting reduced to a single number. So mathematically, are we reducing number of pixels or not?
Right.
Similarly, I will move my kernel to entire image. You got it?
But how this means? What is the significance of this kernel?
You just understand first the operation. I will tell you the significance also.
Okay.
You understood the operation, math operation.
Yes.
Arithmetic is understood.
Yeah.
Then I'll tell you the significance. You will understand significance also. Now you see, this image you see this red rows you see. Once you do complete convolution on this with some filter, it becomes like this after convolutions. It becomes like this, okay? I'll give you few more examples. See, you see this image. This is the original image on the left-hand side, rows image. You have a convolution, you have done convolution, now it reduced to simple edges. Got it?
Yeah.
So what you have done, all detailing of the image you have thrown away, only edges you have kept. Understood? So with this edges also you can make out that it is a rows. Then why you need in between pixels when you can make out with this simple image with much lesser number of details you can make out it is a rows. Then why you need all the details of left hand side image? Do you need? Is it understood?
Yes.
So you have reduced the number of details. That's how it convolution, like when you apply convolution operation to the left hand side image, it reduces to the something like right hand side. Understood? Now understood physical significance.
Yes.
Now I will show you one more image, like one more image I will show you. See, this image you see on the car image. You see the walls, how brightly illuminated they are and the car is standing. I have done convolution and see how it becomes the right hand side image. My job here is to recognize car, is not to recognize background. So what I have done? All the details which are there in the background, I have diluted here. You see the blur, now they are blur. Wall is blur on the right hand side. You see, wall is blur, right? So if wall is blur, that means I'm taking less number of details now from the image. If I do one more layer of convolution on the same image, maybe wall will become further blur. And only outline of the car will remain. But with the outline of the car also, I can still recognize it is a car. So when I need only car outline, then why I should keep the background? That is my challenge. So with convolution, I'm taking what is required. Understood, na? Understood?
But
Ma-
this filtering will be means uniformly applied throughout the image or only to the particular area?
Oh no, throughout image also you can apply, and particular area you can apply particular filter. Both are possible.
Oh,
Okay. But whatever we are learning today, we are applying one filter throughout the image.
okay.
Okay. Whatever we are learning today is applying throughout the image. Okay. So that is one example. This is another example. Now pulling. Pulling means what? Now this is convolved image on the left hand side. Whatever that's the convolution, you have this image. Shrutika madam, you are able to understand, right?
Yes, sir.
So now you have this colored convolved image with yellow, red, green, and blue things. Now I am doing pulling. I am applying a filter of by 2 of 2. Pulling means I am doing max pulling. So what pulling is doing, you see, max pulling means from blue I am taking maximum number, so it is coming 9. From green area I am taking maximum number, which is 7. From yellow I am taking the maximum number, which is 8. And from red also I am taking the maximum number, which is 6. So after the convolution step, I am doing pulling, and whatever I have done right now, I call it max pulling. Is it understood? Further reduce the number of dimensions. Understood?
Yes.
After convolution, convolution means I have multiplied, I have overlapped the filter on image. I have multiplied the corresponding cells and added up. That is one convolution. After convolution, I am doing max pulling. Max pulling means what? I am just taking the maximum thing. That what is the meaning? What is the meaning? What does it mean physically? Physically, it means that in the blue area, what was the most prominent feature that I am taking that? 9 is the most prominent. 9 is representing most prominent feature, and most prominent feature is generally bright. So I am taking the most prominent feature. From green area, I am taking the most prominent feature. From yellow area, I am taking the most prominent feature. From red area, I am taking the most prominent feature. Understood? So this is one kind of max pulling. Malini madam, is it understood? Shailesh?
Yes, sir, it's understood.
Yeah, it is.
Understood, na?
Yeah.
So same thing I am showing here, max pulling once again with a different example. So I need not repeat this slide. Average pulling. So average pulling is another type of pulling where I don't do max number. Instead I take the average. So in the orange area I have taken the average, which is 2.75. In gray area I have taken the average, which is 1.5. Blue area I have taken the average of this 4 number, which is 4. And in that yellowish region I have also taken average, which is 2.25. It is called average pulling. Understood? So if position of object is not important, max pulling seems to be better choice. If it is, it seems it seems that better result can be achieved through average pulling. Means in the image, Shailendra Kadre's photo is coming on the right corner, left corner, or bottom corner, or anywhere. It is the position of the image is not important. Anywhere, but you want the only image. Shailendra's face you want. That case you go for max pulling. But if position is important, in some applications, position is important. That it should be in center. Then in such a case, you need average pulling. More than that, exact details you will not get anywhere. That how position is not important, then how position is important, why average pulling is more. So you just for the rule of thumb, let us assume that if position is not important, let us go for max pulling, and if position is important, let us go for average pulling. Got it? You are not telling anything. Anybody? Uday Soman, any comments? Any comments? So you know when to take what. Other than that, why when position is not important, when we have to take max, and why when position is important, we have to take average. So that's where these details we are not going today. But these are the rules of thumb. When position of image inside the particular is not important, then go for max pooling. If position is important, you go for average pooling. More than that, details we are not going today. Maybe if you want, then we can do more R&D and do some more internet search, and we can discuss it further in later classes, or informally we can take it up. And see, same thing, same figure with max pooling and average pooling. Is it understood? You just have these 2 points. Same image, after convolved image, I am doing max pooling, I am getting this 15, 8, 8, 17, and if I am doing average pooling, I am getting 10, 5, 5, 8. Is it understood? Shailesh Kadre?
Yeah, it is clean. Yeah, clear.
Clear, na? So very simple. Now, there are more type of pooling. This is global max pooling. Concept is very simple. Global max means whatever area I am considering, I will take the max of that. So if this area is 4, 3, 1, 5, whatever 4 by 4 image is there, 4 by 4 pixel, maximum is 9, so I will take only 9. That is global max pooling. Okay. So means global layer means if you want to further reduce the dimensionality, then you go for global max. And sometimes flattening layer which is there in that at the end, flattening layer. So that flattening layer is sometimes and sometimes even dense layer they are replaced by this kind of global pooling. Flattening
So-
layers and yeah.
This global pooling, how it is different from max pooling?
Madam, max pooling means you understand one thing. See, max pooling means what we are doing. 4 times I am putting my filter here and here, right? And in global pooling, I am not putting my filter only for full image. I am taking only the max.
Okay.
See here out of this 4 by 4 image, I am getting a 2 by 2 image after max pooling. But in global, I am getting a single number, 9 only.
Okay.
So what is the use means? Max pooling reduces the dimensions, but global pooling will further reduce. Take it now. So their use cases are given that in place of flattening layer, wherever you have flattening layer, there we use global pooling layer, and sometimes even dense layer we are replaced by global pooling layer. But so far, in whatever CNN models I have done, nowhere they have used global pooling. So either we generally we use max pooling. Maximum of the cases we use max pooling, and average pooling also. I have not, at least in my limited experience, I have not said average pooling also. Global I have never seen using, but they are telling if you want to replace, in some cases, flattening layer they replace by global pooling, and some dense layer also they replace by global pooling. So details of that are not available with me right now. But generally, I have not seen this getting used anywhere. Maybe in some advanced CNN, they might be using it. Then another is very simple concept. Instead of taking the here global pooling, we are taking the max. Here we are taking the average. All the average of all metrics we are taking, so average is 4.3 here. Okay. So here also, like they are often used to replace fully connected or densely connected layers in the classifier. Means this kind of average layers they are often used to replace the fully connected or densely connected layers in the classifier. Instead, the model ends with a convolution layer that generates as many features maps as the number of target classes and applies global average pooling to each in order to convert each feature map into one value. Understood now? So instead of having densely connected layer, they are not having any densely connected layer in the neural network. Instead, they are reducing it it with this kind of average pooling. And at the end, suppose there are 3 feature maps and you want 3 classes. So 3 times they will take average and they will reduce it to like this. But again, in my limited experience, whatever CNN I have used so far, they always have convolution pooling and they always have densely connected layer. But he is telling, like, somewhere I have read this. So I just wanted to show you that some people, like some advanced applications, they just remove the dense layers. And if you have 4 water feature maps, we will study tomorrow. So suppose you have 3 feature maps. So with each feature map, they are telling average. And if you have 3 classes, like that, 3 times they will take the average and they will determine which class is it. There is no dense layer in the CNN application. But in my limited application, at least I have not seen. This global layer, a global like max pooling and average pooling. Yeah, of course you will find many times. But this global max pooling, global average pooling, these 2 things I'm just giving you for the sake of completeness, for the sake of showing that these kind of things also exist. Means it would have been better that I have not confused you with global and average pooling, global average pooling. I would have removed it. So for now, you remember that there are only 2 types of pooling. One is max pooling and one is average pooling. These 2 you will encounter in the common types of CNNs. The rest you forget for now. Just we have, for the sake of completeness, we have seen it. But for all your practical purposes, you will find either max pooling or average pooling. And that too, 90% of the time, you will find max pooling. Okay, so this is what pooling is. So now pooling is understood and convolution is understood. These 2 are very important concepts. If you want, we can go one more step, one more time. And I think I am done here. I'm done for today. And if you want to go convolution one more time, we can go convolution one more time. You want pooling or any other concept you want me to repeat, I can go. Or you want me to repeat complete lecture one more time. So I will repeat one good revision in 5 minutes. So CNN is nothing but a special form of ANN, which we use for image recognition. That is one. That's why we use CNN. Why we use CNN? Why don't we use ANN? Why don't we use ANN? Why we use CNN? Because number of features are very large. So what we do to reduce the number of features? We do first convolution and then we do pooling. And we can have many layers of convolution pooling, convolution pooling, convolution pooling. So this is nothing but feature extraction. One feature extraction is over, then we have densely connected 3-4 layers, densely connected ANN layers, and lastly we have a output layer with number of neurons equal. So what is the image? Image is nothing but a square, small square portion of unit small square portion of the image, which is having values between 0 to 255. What is 0 to 255? 0 to 255 is the intensity. 0 means black and 255 means white. Every color image will have 3 channels, RGB, red, blue, green, and each channel is 8 bits, so it is 24 bits. So like this, it is represented. If I combine this RGB here, it will become the normal image. Same thing I have shown here. Then it is the important representation of a grayscale image. It is represented in the left hand side with the help of pixels. You understand that now? Then again, RGB image shown with the help of pixel map. R you have 0 to 255, GB, like that you have. And when you keep all the 3 on the top of each other, it becomes the normal image. Challenges. So one is the viewing angle, is one challenge in dealing with images. Then you have scale. Then you have background or clutter, whatever is there. Then you have illumination. Then this is the general architecture of CNN model. So first you have feature extraction layers. Feature extraction means input, convolution, pooling. That is feature extraction. Once the features are extracted, we feed it to a normal ANN, which are densely connected layer. In the last, we will have output layer with number of neurons equal to number of classes. Okay, so this is the general. These are two pairs of convolution pooling, two fully connected and one softmax. So this is general architecture. Then so we know when to put softmax and when to put sigmoid. We know that. Again, same thing. CNN applications, very simple. Then again, I have seen one more thing here we have to learn is, along with every convolution layer, we use a ReLU function, which is the activation function. So activation function in every CNN, generally what we use, ReLU1. And one more thing we learned here, that when feature extraction is over, it is a 2x2 kind of multi-dimensional feature map that we have to convert into a single line, a single column vector before feeding into the fully densely connected layer, which is ANN. Before feeding into ANN, we have to flatten it. Flatten means what? From multi-dimension, we have to convert it into a single dimension, because ANN input is always single dimension. Then this is one example I tried to show that how from an actual image we extract features. That's what I tried to show. Then convolution. Convolution is nothing but image is there. Between each image value is between say 0, 1 or 0 to 255, and then we have a smaller filter. So we convolve the filter all around the image, and with every convolution we'll get a reduced set of image. That's what we get. So if we do full convolution of I image with the K filter, you will get this I into K kind of image, which is smaller image. So we have reduced number of dimensions. Once convolution is done, then we'll do further pooling. We'll do pooling. Pooling is max pooling. Max pooling means wherever I will pull region, that max I will take. And another is average pooling. Instead of max, I will take average. So with pooling, I further reduce the number of dimensions. Then this max pooling you know, and then average pooling. These two kinds of pooling are there. So pooling and convolution are nothing but dimensionality reduction. But arithmetically, these are two different operations. In convolution, we do element by element multiplication. And in pooling, either we take max pooling, we take the max of that area, or in average pooling, we take average of that area. Only these two types of pooling are important right now. So after one example I gave you, see how clear image background is. The background of that image, you see the high white wall, the lamps and all, how clear they are. After convolution, you see they are little blurred out, because we don't need that image. We are not dealing with the walls or the lamps. We have to deal with the car. So car image is important for us. So we are blurring out all the backside images. So it is for then after convolution image, if you do max pooling, see very nice example. Left hand side is the convolution image and right hand is the max pooling. Further reduction in details. But still car you can recognize. You can recognize the car, CNN also can recognize the car. So convolved image is on the left hand side. See here first. Here original image. After convolution you get right hand side image. That is convolved image with the help of convolution. Then you keep convolution image. You do pooling on that. You get the right hand side image. You get some idea. It is, you see the convolved image. Convolved image, you see little details are still seen. But pooling means you have further blurred out the background. That's what convolution and pooling is. And this is my class break one. I have finished 36 PPTs, and some important concepts are delivered, which are very most important are convolution and pooling. They are nothing but you have to reduce the dimensionality, but fundamentally, arithmetically, they are different operations. And when we do max pooling means what? They say that most important feature in that particular area should be the bright. So they take the max of that figure. So it is max pooling. And they sometimes take the average. But I said 80-90% of the time you will be using max pooling only. Convolution is only one type. You just multiply the elements of kernel with elements of corresponding element of the image editor. It is only one type of kernel. Then once one place is done, then you go right hand side by 1 or 2 columns. Sometimes we go by 1 column, sometimes we go by 2 columns, depending on how much detail we want. So that also we'll see in the future lectures. That is called stride, going right by 1 column or 2 column or 3 column. So that also we'll see in the later lecture. Tomorrow we'll finish that. So these are the concepts. I think look very simple. If you see once again, you will feel that we have not done anything today. But if you don't do these things, you will not be able to understand CNNs. Lot of things are delivered if you see it that way. But if you see, they are very simple concepts. Very simple concepts are done, but very important. All image we have dealt and 2 basic operations of convolution and pooling we have done. So I think I'll keep open for a couple of questions, and after that we can close. So first question should come from Gesu guys here. Is this understood? This was the first class, and more technical details of CNN will cover tomorrow. These are only basic concepts of CNN. Basics of image, basics of convolution, basics of pooling. So any questions, Gesu guys? Himanshu?
No, sir, it was easy so far. It was
Easy,
easy
na?
so far.
Yeah, thanks. Any Shailesh or Malini madam, Shrutika madam understood?
No questions, sir.
No,
No
actually, in
questions.
this,
Why, madam? It is not understood, no questions, or all understood, that's why no questions.
The concept was fairly simple. You apply a filter and then you have a max pooling.
Yeah,
That part I have understood.
understood. That's all only. That's what we have covered today.
Actually, is there
So,
any relationship between the size of the kernel and the
Yeah,
picture
yeah,
or
yeah.
pixel which we are looking
yes,
at?
we have definite, and we have formulas for that. So we'll cover those formulas tomorrow.
And second thing is, what I see is in kernel, we have a diagonal matrix with some digits and out diagonals are 0. So is there any specific thing for that?
No, we don't get into we keep it simple only. We don't get into diagonal elements and all that. We just first keep on the edge, then we just go right, then that way we cover all the image. So diagonal and all, we don't get into that complications. It is not required for convolution.
No, what I mean is in kernel, we have a specific thing, na 200, then 00 something was there, right?
Yeah.
So is there any is it a common means while?
No, you have 1,000 type of filters.
Oh, okay.
We'll see that to extract different type of to extract horizontal line, you need different numbers in kernel. To extract vertical lines, you need different numbers in the kernel. You have 1,000 type of filters.
Oh, okay.
So that also we'll cover tomorrow.
Okay.
Very relevant question, very nice question. Thanks. So we have a different type of kernel means in kernel size will remain the same 3 by 3 or 2 by 2 kernel.
Yeah.
But numbers in that will change.
Right. Zero.
So that's what will change the kernel, right?
Yeah.
The image will remain the same. Input image will remain the same. But kernel will keep on changing, but depending upon what we need. Whether we need to extract horizontal line, whether we need to extract vertical line, or we need to extract more details, other details, so kernel will change.
Okay.
And this kernel is, we don't have to decide what kernel to use. That is automatically decided with the help of, at the time of CNN training, it automatically finds out the weights in the kernel. That is called weights in the kernel, right? Now values in the kernel is called weights. So those weights, CNN automatically finds out at the time of training. That is the beauty of CNN. We don't have to decide which filter we have to use.
So
That is automatically determined by CNN at the time of training.
So in ANN, just like we decide for the weights and the biases, like here.
No, in ANN also, we don't decide weights and biases. In ANN, weights and biases are automatically calculated at the time of back propagation, right?
Right.
Which is training of the, which is nothing but the training of ANN. Understood?
Yes.
So similarly here, weights and biases means weights of filter, numbers which filter size will give 2 by 2, 3 by 3, the size will give. But inside that, what weights or numbers should be there, that will be determined automatically by the CNN. By at the time of training of CNN, which is back propagation of CNN, at that time, they are getting determined automatically by the computer.
Okay.
We don't have to deal with it.
Okay.
Got it?
Yeah.
Any other question? And there is a definite relation between image size and filter size. And how much you are going right now, that is called stride. STRID, stride. So how much ride we go at a time? That also has an impact on image size. So those formulas are there, and if you are doing any course, they are definite exam questions. Like in my MSc, they were exam questions. They will give filter size, they will give image size, they will give the stride, and they will ask you to calculate the output image size. So that is the exam question. But here there is no exam, so you can conveniently forget if you want.
Okay, I think I got it.
Got it, na? Any other question? Guess you guys, no question is coming from your side. Himanshu, Sudha, wo hai ki nahi, bhag gaya wo? What about Shubham? Shubham's there? So gaya lagta. ठीक है. Anyway, so if there are no questions, then I think we can end here. That's what I had planned today. See, arranging this PPT is also, see how painfully they are. See, this is the relationship. This is the relationship between output image and stride and filter and all that. So collecting this many, I have today covered till 36 slides. But there might be, I have searched maybe more than 25 articles to get this kind of images and values. Just to get this 36 slide, I have scanned more than 25 articles. All article names are given below, you see here. So it's a very lot of labor actually. It's not that easy to find out all so much. See these images, na? After convolution, it becomes like this. Convolution after pooling becomes like this. You try to search in the internet, you will get real tough time to get any such example in the internet. And all are copyrighted. So I have given their reference here in the down here all. So search is very painful, real. So with this, I will end for today night.